Of deep learning. So in the previous section we have learned the mathematical operations of TensorFlow. In this video also we will learn few TensorFlow operations. Those are very much necessary and essential parts of deep learning module. So first I am importing warnings because by default the code generates so much different kinds of warnings over there. So I'm going to ignore each warning. Then I'm import TensorFlow library in my code. By default my TensorFlow is having version of 2. I can change in the version of 1 also. Then I'll create two constants, that is x and y, that is 1 2 3. These are TensorFlow constant, not the ordinary one. So in the TensorFlow, what do I mean when I say TensorFlow constant? What do I mean? Just vector form of this TensorFlow. I'm having 1 2 and 3. Similarly, the second variable I am taking as the format of 3 2 1, and then having the assigned to the x and y respectively. I'm going to perform few basic operations over here, such as addition. So I'm going to perform addition over here. Okay, so I'm going to explain why I'm using TensorFlow over there. So what's happening over there? Suppose you create a list, like I'm creating any list 1 saying 1 comma 2 comma 4, and the second list I'm going to create list 2 with certain constant value, let's say 5 7 and 9, and these two lists are having same dimensions. I just create it over there, and then what I do, I create just third list. I'm having list 1 plus list 2. So I'm having plus operator in between first list and the second list. So according to the code, or according to the mathematical operator, it should be printed, it should be add mathematical operation. Mathematical operations must perform some dot wise operator, like this 1 5 should give like 6, this should be having like 9, and the third value must have 13 over there, but it's not there. Can you see that 1 2 4 5 6 7? So what's the reason over there? So reason behind that, the list, the conventional list are having concatenation function. So this is going to concatenate anyhow, not going to perform the mathematical plus operation. This plus operation is going to perform concatenations over two lists defined over here, not the mathematical operations. So in order to remove that error, I'm having this. What's the solution for that? I'm having TensorFlow. A good news is TensorFlow, that we are going to perform that TensorFlow over there. So we are using TensorFlow because of this reason. Now I'm going to subtract over these two functions, like what was the exact value of x and y, that is 1 minus 3, that is minus 2. It should be O, it will 3 minus 1, that is 2. So that I am obtaining here. So it is going to define the difference over there. Then I am having the multiplication bitwise. So I am having the value of x and value of y, and it is going to multiply in each with each variables, and going to multiply over there. Similarly, I can perform so many tasks over there. Okay, so these are x value 1 multiplied by 3, that is 3, 4 and 1. So my answer of the multiplication, bitwise multiplication, should be 3, 4, 3. That's correct. Now I'm going to divide, bitwise divide over x and y values. So element wise division is going to perform over there. So I'm going to divide these two variables. So that is the division part. Similarly, I can have a square of single values like 1, 2 and 3. That is the bitwise square of element. I can have the square of y also, so I can make square of y values also, that is 941. So I can perform the dot wise product, that is the multiply xy. So that is the multiply xy means, like, what is the value over there? That is the 1 into 3, that is 3, 2 into, so multiply these two elements, that is 3, 2 into 4, that is 4, 3 into 3, that is 3. So I'm going to add these three values, that would be equal to 10. So that 10 value is going to define over there. I'm having that output over there, dot product. So this output is having 10 because of this reduction sum and then multiply x and y. So Tensorflow make easier all these mathematical calculations. So finding the index of minimum and maximum elements, that is the constant index of the argument minimum, that is the 1, O1. Alright. Then I am having the maximum argument, that is 2. So O12, 13 is having index number 2. So I am having that index number 2 over there. Similarly, I can have a square of these two. So that is 1, 3, 5, 7. So that is square difference. That is the 1. So that is 1. So 3, 3 minus 1, 2. That is 2 square. 4, 5 minus 1. That is 4, 4 square, 7 minus 1, that is 6, 6 6 is 36, 11 minus 1, that is 100. Par also, I can do the same thing with par, POW with TensorFlow, and then rank of the function of the matrix, certain extreme, what is the rank of the, so this is having 2 cross 2 with 3 dimensions, so 2 cross 2 and 3. Similarly, I can define x function. Yes, this is the first matrix 2 cross 2, this is the second matrix 2 cross 2, and this is the third shape of the matrix. And I can have defined the constant value of 1, 2, 3, 4, 5 and 5, 6, 7. So I can reshape this constant. So previously it was having 1, 2, 3, 4. So previously the dimension was like, what was the dimension? So 2 rows and 4 columns. Alright, so how would I know that? So I'll just print x over there. I'll print this output. So what's the output? That is 2 rows and 4 columns. So I'm going to convert this 2 rows into 4 column into 8 rows into 1 column. So how can I do that? So I can use reshape function, and that is x, that will being operated on x, and then I'm going to reshape with 8 cross 1. So little things occupy the biggest part of the code. So I'm going to perform this numpy, and this is, you can see that 8 rows and 1 single column. So moving ahead, I'm going to reshape it again in the format of 1 cross 8 also. let's say I'm giving 1 cross 8. So this time it is going to horizontally define. So now I'm going to transpose this function, this matrix 4 cross 2 also. Previously it was 2 cross 4, now I am having 4 cross 2 transpose. I can do the typecasting also. Previously it was constant, now I am having the integer. So it was having integer 32 previously. Then I can have the casting over float values. So I can have this value as float this time. I can concatenate two matrix also. So x is having 3 means what's the dimension of x? How would I know that? I will just print x and then it will print rows into column. Okay. Similarly, I can have the y print. I can concatenate this using concat x comma y with o. So this will concatenate to string, this one 3 3 6 9 7 7 7 4 5 6 5 5 5. I can do the concatenate using column wise also. So 3 6 9 4 5 6 7 7 7 vertically concatenate. I can use the stack over there. So that is the stack 3 6 9 7 7 7. So that is the horizontal stack. I can use the, instead of y-axis, I can use the x-axis. That is the 3 6 9 7 7 7. So this is the next stack format. I can reduce mean also, the variable. So what is the use of this variable? That is the define the different section, like what is the tf dot variable. It is having the numpy function and the numpy value, like tf dot variable. So it will have that explanation part over Tensorflow. So it will find the definition of the variable. So what is the predefined function of variable? And the official site is tensorflow.org. So in this organization you will find all the pre-necessary functions, prerequisite file, and the definition part also we will find over there. Alright, so it is having initially value none, trainable null, validated shape and coaching, and it will take aggregate function also, a variable agent. So in this code we are using this parameter also. So we can have this numpy. I'm going to convert into the number in Python. So I'm having 1 5 2 3. So compute average value of this one. So 1 5 2 3. So reducement is tensor, input tensor is equal to x, that is the numpy. So that is the 2.75, the compute average value of this entire variable. Alright, so average cross the rows. So I can have the input tensor with axis, with x-axis, that is the 1 5 2 3. So I can have the average value of this axis 1 also, means column wise also. When this axis is having 0 means I am talking about rows. When this axis is having value 1, I am talking about column. So keep dimension true, it is going to keep dimension true. So this is 3 and 2.5. Similarly, I can reduce this sum, that is x numpy, and then I find out the 1 5 and 3 comma 5, that is the reduce from row wise because I am having this row function. Similarly, I can sum values across the columns. I can have this 1 this time. So similarly, reduce 1 all these value, that is 11. So we can have the random values in the TensorFlow. How to do that? Random dot normal and then different. Standard deviation 2.0 and then numpy. Mean should be 10 and standard deviation 2. If I'll create that different value, it will give the different section. Similarly, you can have the uniform values. So with the minimum value 0, maximum value none, and then have the uniform random variable. Similarly, I can create zeros over there over the TensorFlow. I can have zeros like x, which is having the same dimension. Similarly, I can create the ones over there. Similarly, I can create x with the same direction, with the same dimension, and then compute softmax probability over the 7. So what the softmax function, that is 1 upon e raised to power x. So in the Google, if I write that 1 upon 1 plus exponential of minus exponential of 7, let's say what's the answer over there. Okay, so it is 0.009. so here we are obtaining 0.8756, that is the softmax function. Similarly, we can have the I matrix, that is the TF over I7. This is the I vectors. Similarly, we can have the L2 normalization over the epsilon. Similarly, gradient computation, how to calculate the gradient computation, we can find out. And TensorFlow is lot more than this. We will learn and explore various important functionalities of TensorFlow as we move forward through this video series. In this next section, I'll have the hands-on practice about a new version of TensorFlow called TensorFlow 2.0. Thank you very much.